Hello, everyone. My name is Imalia Diego, and I'm a Junior Applications Engineer here at Chroma System Solutions. I want to thank everyone for joining me today, and I hope everyone finds themselves safe and healthy in these strange times. Today, we'll be going over the key features and functions of our new lower power regenerative grid simulator. This series allows users to vary parameters in order to simulate real-world grid environments and conditions, facilitating its use to test equipment such as residential PV inverters, EVSEs, electric vehicle bidirectional onboard chargers, and residential and small energy storage systems, along with other green energy products. I'm going to please ask everyone to remain muted and hold your questions until the end, or you could also send your questions through the chat where Larry and Sean will also be assisting me with answering questions during the webinar. Okay, so why did Chroma make the lower power regenerative grid simulators? Traditionally, the regenerative grid simulators have been designed and priced for higher power applications. However, with this new release of regenerative grid simulators, the residential and EV industry can now have a smaller, more affordable, lower power regenerative grid simulator to closer meet their needs. So why do I say this? Well, if we look at the chart I've included on this slide, you guys see here the bottom left-hand corner. This is a chart from EIA in 2019. The average annual electricity consumption for a U.S. residential utility customer was about 10,600 kilowatt hours, an average of about 877 kilowatt hours per month, which is about 30 kilowatt hours per day. And because of this, most residential solar systems being sold are usually around the 30 kilowatt or less range. I've included this picture here, the top right-hand corner. We can see one company's different models it has to offer. You can see it. There is a 4 kilowatt option along with an 8 kilowatt, 12 kilowatt, and 16 kilowatt options. There are also standards such as the SAE J1772 standard, which is also known as the J-plug. It is the North American standard for electrical vehicles. It's the North American standard for electrical connectors for electrical vehicles. Both level 1 and level 2 are under 30 kilowatts, which can actually be achieved by paralleling two 61815s. And even with two 61815s, you're looking at a total of a 6U cabinet height and 100 pounds each. Versus a whole rack's worth of space and almost 2,000 pounds. So the lower power applications can really take advantage of this smaller size and lower power, which actually gives you improved measured current and power since you are now in a closer range. And we can see here, this is the 61815 15 kVA unit. And on the right, we have the 61860 or 60 kVA unit. Okay, so let's get started with a brief overview of the key features of this new regenerative grid simulator family. The family has 3 different models ranging from 9 to 15 kVA, 0 to 350 volts, 0 to 35 amps, 30 to 100 hertz, and it's also capable of you're also able to vary the slew rate for voltage and frequency. And they have a wide AC input voltage range that's capable of supporting three-phase input voltage ranging from 200 to 480 volts. This family is full four-quadrant regenerative. It is a regenerative unit, and it's packaged in a 3U height design to minimize the space occupied in the system cabinet. You do have the capability of paralleling more than one unit to achieve a higher power, and it has a selectable one or three phase output, as well as a selectable AC, DC, and AC DC output. From the front panel, you can access the advanced modes, which include list, pulse, and step mode functions, along with harmonic measurement, the synthesized waveform function, and the interharmonic function. You can also choose to display up to 3 measurements on the front panel for different parameters, and it comes standard with USB and LAN interface and has optional CAN and GPIB interfaces. It also has an optional soft panel with IEC 61000 tests that is available for purchase. Okay, now let's briefly go over the 3 different models that we have available. We have the 61809, which is a 9 kVA unit, and it has a 29 amp current maximum output in 3-phase mode per phase, and 87 amp maximum current output in 1-phase mode. We also have the 61812, which is a 12 kVA unit, and it has a 32 amp current maximum output in 3-phase mode per phase, and a 96 amp maximum current output in 1-phase mode. And lastly, we have the 61815, which is rated for 15 kVA, and it has a 35 amp current maximum output in 3-phase mode per phase, and a 105 amp maximum current output in 1-phase mode. And the entire family of regenerative grid simulators has a 30 to 100 hertz frequency range. So, one really great feature of Chroma's regenerative grid simulator family is that they support a wide AC input voltage range. However, when using the 61815, which is our 15 kVA unit, with a 220 VAC input, the power is actually derated to 80% of the output power. That is, of 15 kVA, you can only use 12 kVA when connected to the 220 AC input. Though this limitation does exist, this is still a really great feature because you don't require any hardware or software modifications. You don't even have to set a switch. It will just automatically detect your AC input, and it will derate it if necessary. So that means that you can't damage the unit by connecting it to the wrong AC input. And another great feature of this product is that when it is acting as a load, the grid simulator is regenerative with an 87% efficiency, putting power back onto the grid instead of dissipating it internally. This is a really great feature when testing in AC load mode or with bidirectional applications, because instead of using a very large AC load and an AC load and a separate AC source, you can now just use our regenerative grid simulator, which acts as both the load and the source while putting power back onto the grid. Okay, our regenerative grid simulator family will also operate at a wide current and voltage range and is still able to achieve full power as a load or as a source. So in this slide, I've included a few examples. We can go over the 61815. So you can see that, and that would be this line here. You can see that if we were set the output voltage to 350 volts, which is the maximum voltage output, we could still set the current up to 15 amps and still achieve 15 kVA maximum power. Alternatively, we could set the current to its maximum output, which is 35 amps, and set the voltage to up to 150 volts, also resulting in maximum power. And really, you can do any combination of voltage and current setting as long as their resulting power output does not exceed the maximum power rating. And this makes this unit more versatile in operation so that you're not limited by reduced power when you reduce the voltage or current. Okay. Another really great feature of our regenerative grid simulator family is that it can operate in all 4 quadrants and has a regenerative design. That means that it's capable of withstanding 100% reverse current, so it acts as a source and as a load. Here in the middle, I've included this diagram. We can see how we can see how each quadrant is related to the voltage and current polarity and whether it's sourcing or it's loading. On the left-hand side is an example of when the regenerative grid simulator is acting as a source. We can see how when the current is positive, so is the voltage, and the same when they're negative. So when the current is negative, the voltage is also negative. And on the right-hand side, we have an example of when the regenerative grid simulator is acting as a load. Here we can see how when we have positive current, we have negative voltage. And when we have negative current, we have positive voltage. So when acting as a source, it operates in the 2nd and 4th quadrant. And when acting as a load, it operates in the 1st and 3rd quadrant. As a load, the power generated by the DUT can easily be fed back to the grid rather than dissipated as heat. And this is a great feature because it will lower the cost of operation. It reduces the need for air conditioning. And it also protects the environment in the long run. So our regenerative grid simulator family also has a selectable 1 or 3-phase output. You do have to physically wire the unit differently when you use 3-phase versus 1-phase. You can see here on the bottom left-hand corner is the 1-phase connection, and there's a jumper between all the phases, line 1, line 2, and line 3. This is a great feature. So the single phase output mode is a great feature for higher current single phase components. You can reach up to 105 amps in single phase with the 61815 15 kVA unit. It also has a selectable AC-DC or AC-DC output with a maximum of 15 kilowatts, 495 volts, and 78 amps DC output. And we could actually, if we look at this image here, we can select the AC-DC or AC-DC output from the front panel screen. Okay. And as I mentioned earlier, the regenerative grid simulator family does provide parallel output capability. Though this parallel configuration is only for 3-phase output, This feature enables the users to extend the output power by connecting up to 3 units in parallel configuration. That gives you a maximum total output power of 45 kVA with our 61815 15 kVA unit. So if you parallel 3 of our 15 kVA unit, you'll get that 45 kVA maximum total output when paralleling. And this is a really great feature for testing smaller energy storage systems or power conditioning systems that are more directed to the commercial or non-residential industry. It also reduces the amount of space needed in a cabinet because you'll only need about 9U height, so that's 3U per unit, instead of an entire rack. The Regenerative Grid Simulator family is capable of simulating various power grid abnormalities and disturbances. They provide power line disturbance output waveform programming functions such as step, pulse, and list programming modes. It also has the harmonic synthesis and interharmonic functions. This enables the user to simulate various power grid abnormalities and disturbance conditions required by international test standards. You can also simulate conditions such as cycle loss, transient peak, and power attenuation. In the bottom, we can see list mode, pulse mode, and step mode. With list mode, you can create a sequence of waveforms and make that a waveform. In step mode, you can create a waveform with gradual increments or decrements. In pulse mode, you can program a particular waveform and attach it to the normal output. And again, we can see that from the front panel, we can choose these different modes of operation. Okay, so now the synthesis function, the harmonic function, and the interharmonic function, along with the waveform viewer of synthesis function. The synthesis function is used to generate a waveform up to the 50th harmonic level based on the 50 hertz or 60 hertz fundamental frequency. The interharmonic waveform can be used to program the interharmonic frequency and components, as well as to sweep and overlap the static fundamental waveforms. The harmonic measurement can measure the related power parameters, such as the total harmonic distortion, DC voltage, and fundamental frequency, providing harmonic measurements up to the 50th orders. And the waveform viewer can be used to view the real-time output voltage and current waveform. You can actually choose up to 3 waveforms to view. And as I mentioned, the Regenerative Grid Simulator does have measurement capability. It has the ability to measure the related power parameters provided on this slide, also providing harmonic measurement up to the 50th order. It can display 3 measurement items in the main setting screen, such as voltage, current, and power. You can set each phase to 3 different measurement items for display on the main menu. You can also choose to view the main screen in display mode to expand the measurement values to full screen, making it easy to see and document. And the grid simulator does also have a screenshot capability that will let you take a screenshot of the front panel display and easily save that onto a USB host. The images that you guys can see here were used using the screenshot option, and I was easily able to upload the pictures to my presentation. So you can use the measurement function to select what measurements you would like to look at. And you can do this for all of the phases, or you can select different parameters for each phase individually. And then you can put it in display mode to easily see the data and capture a screenshot if necessary for data reports, presentations, or whatever it is that you may need. Now we'll get a little bit into the optional soft panel that the Regenerative Grid Simulator has. It's an optional soft panel available for purchase. It's a graphical user interface specifically designed to provide users with an easy to use interface for controlling the instrument. It can perform internal parameter settings for the AC source and monitor the output measurements. It can also preview the simulated output waveform so that before sending the parameters to the unit, the screen will display the output waveform for previewing. The software is also able to save the parameter settings so that a user can open an existing file for execution from the hard disk. And it is equipped with data recording functions, allowing multiple measurements to be recorded and saved simultaneously. The screen that we see here is fixed mode, and this is our standard sinusoidal output mode. This family can not only program a stable sinusoidal output voltage and frequency, but also provides features to simulate power line interrupts and distorted waveforms. In list mode, there are 100 frequencies that you can set in order to achieve this. This is our most versatile mode, as you can set each sequence to have different parameter settings for all the parameters. That is, for each sequence, you can have a different cycle runtime, a different frequency, a different waveform, and voltage, or really any of the parameters that you see displayed on this screen. I've included an example waveform that you can achieve using fixed mode. There was 3 sequences programmed to start at 20 volts and end at 120 and 120 volts. Sequence 1 has 100 VDC voltage end, and sequence 3 has a 100 hertz frequency end and runs for twice as long as 1 and 2. So here in red, these are all the settings that I set inside of this soft panel here to create this waveform capture on the oscilloscope. So with pulse mode, the user can program a special waveform and add it to the normal output setting in the main page. This mode can be used to simulate undervoltage, overvoltage, sags, and swells for testing any grid-tied device. In this example, the nominal voltage is 50 volts and 50 hertz, and the pulse voltage is 100 volts and 100 milliseconds, period, with a 35% duty cycle. So again, these are all the parameters that I had to set inside of the soft panel to achieve this pulse waveform. With step mode, it provides you a simple auto switch function that changes the output voltage by stepping. This is a good tool when testing for a product's overvoltage and undervoltage limitations. In this example, the fundamental voltage is set to 40 volts and the frequency is set to 50 hertz. The stepping voltage is 10 volts and the stepping frequency is 10 hertz. The dwell time is 60 milliseconds and has a stepping VDC of 10 volts. And in red are the exact parameters that I set to again obtain that waveform capture from the oscilloscope. The synthesis waveform function can be used to create complex waveforms. The harmonic components range up to the 50th orders, with the fundamental frequencies limited to 50 or 60 hertz. The user can program 6 types of synthesis waveforms to execute or save for a later time. In this example, I set the VAC at 100 volts, the fundamental frequency at 60 hertz, VDC to 0, and I injected 30% on the 7th harmonic. The interharmonics function can be used to simulate the combination of any two different frequency waveforms. You can set the start and end frequencies for scanning within a period of fixed time, and then add the varied levels to the fundamental waveform. It can also measure the 50th order harmonics of voltage or current and display the value such as fundamental voltage, DC component, and total harmonic measurement. Total harmonic distortion. The soft panel also comes with IEC regulations tests such as IEC 61411, IEC 61413, IEC 61414, and IEC 61428. I listed some of the tests included with these standards, such as voltage dips, short interruptions, voltage variations, and you can actually edit these and partially edit the parameters so that you can modify it to fit your specific test needs. With the waveform editor, the user can input the harmonics into the table, and the blue panel cell will show the simulation waveform. You can also import a CSV file from Excel with your custom waveform. So you can do that here. We can see that there's an option, there's a tab here that says from Excel. You would import that CSV file that contains your custom waveform, and then you could save that and send it off to the unit for later use. So it can be saved into one of its user-defined waveforms. It also has a report generator tool, which is used to record the selected readings. It could log each reading up to a 1-second interval. So you can choose here what settings it is that you want, what parameters it is that you want to record, and then it'll return a document with those values. Okay, so now we're going to get a little bit into the applications. The Regenerative Grid Simulator tool is good for testing applications for products that are in areas such as the electric vehicle and plug-in hybrid electric vehicle, which has components such as onboard chargers, bidirectional onboard chargers, electric vehicle supply equipment, and wireless charging equipment. They're also good for testing products in the green energy industry, which include PV inverters, power conditioning systems, and energy storage systems. Some of these applications need to be compliant with standards such as the IEC 61000, the IEC 62116, the IEEE 1547, and SAE J1772. And the Regenerative Grid Simulator family can meet the requirements of test applications required by these standards. We'll be going a little bit more into detail with bidirectional onboard chargers, PV inverters, and power conditioning systems. An onboard charger is used in an electric vehicle or plug-in hybrid electric vehicle to charge the car's battery system. Onboard chargers are typically less than 15 kilowatts due to size and weight restraints when added to the electric vehicle. A bidirectional onboard charger is very similar to an onboard charger in that it charges the battery system, but very different because it also has the capability of discharging the battery system, allowing energy to flow both ways. You can use the battery power as backup power for your home during blackouts, also known as V to H or vehicle to home. And you can also use it to put power back to the main electrical grid, also known as V to G or vehicle to grid. And lastly, you can use it to connect to a common AC load, such as a television or a fan or any common household appliance, also known as V to L or vehicle to load. So in this image that I've included, we can see how the bidirectional onboard charger gets its power from the EVSE, which gets its power from the grid. But the bidirectional onboard charger can also put power back onto the grid, which is why the yellow arrows point both ways. This functionality is typically referred to as V to G or vehicle to grid. In this case, the regenerative grid simulator can act as either the source or load in the V to G connection. We can also observe the regenerative grid simulator can act as a load when there is a V to L and V to H type connection that needs to be tested for the BOBC. So it will not just act as the grid being regenerative and putting power back onto the grid, but it can also act as the load, acting as a load, taking power from the battery system. There are certain tests that any bidirectional onboard charger must go through, such as charge and discharge test, over voltage and over current test, and anti-islanding test, among many other common functionality tests. Also, anything that puts power back onto the grid has various standards it needs to meet before it's allowed to put power back onto the grid. Our regenerative grid simulator family has the ability to test for these various standards, including the IEC 61000 and SAE J1772. And it has the ability to do this because it has the ability to control the voltage waveforms and various transients to test the susceptibility of the bidirectional onboard charger. For example, with step mode, you can test for overvoltage, creating a waveform that slowly ramps the voltage. Typically, to do this kind of test for a bidirectional onboard charger, you would have to have a very large independent AC, conventional AC load, and you would also need a separate AC source. However, now with our product being a nice compact 3U package at 15 kVA, you can do all of that in one unit. It gives you the ability to act as the grid when needed and to act as the source when needed. And it will put the power back into the grid when acting as a regenerative load rather than dissipating it as heat. We'll also be going a little bit over the PV inverter. A PV inverter is a key component in a solar system. It's a device that changes DC power to AC power. It takes the energy from the sunlight with solar panels and converts it into AC power for either storing or putting back onto the grid. Just like the BOBC, It also has various common functionality tests and standard requirements that it must meet before it's allowed to put power back onto the grid. Among the tests required are voltage fluctuation immunity test, voltage dip tests, and short interruption tests, along with many other common functionality tests, some of which are included in standards such as IEC 61000, IEC 62116, IEEE 1547, and the IEC 1547. Sorry, I already mentioned that one. So with the IEC 61003, that standard limits and measures the methods for low frequency emissions on the AC mains, while the 61000-4 sets limits on the susceptibility or immunity of the equipment powered from AC mains. And our regenerative grid simulator family includes advanced power line disturbance programming functions and is capable of simulating various types of distorted voltage waveforms and transient conditions. With these programming modes, voltage waveforms required by the immunity specifications, such as the ones that I previously mentioned, can be easily achieved. For example, with list mode, we can simulate a short interruption test. And again, before the bidirectional capability of this unit, you would need a very large AC load and a separate AC source with a very large resistor for load simulation. However, now you only need our 15 kVA regenerative grid simulator. And finally, we will be going over the PCS system. A PCS is a collection of electrical equipment that converts DC from a solar system to AC. It has monitoring devices and isolation switches that can isolate the solar energy facility from the bulk electricity grid during off-normal conditions that could jeopardize or damage either the facility or the grid. The regenerative grid simulator can simulate these various power line disturbances that the PCS may encounter, including harmonic and interharmonic tests, voltage variation tests, and power frequency immunity tests. Again, it can act as a load when testing its ability to supply power to the loads, such as common household appliances, or it can act as the grid, both taking power and giving power back to the grid when necessary. So that finalizes our webinar. Thank you so much for watching. And if you have any questions, now would be the time to ask.